and history repeats itself. Okay. What we've got here is a flying pig problem. It is actually, if you watch the previous video, a pitched circular motion problem, and it's looking at the left side here, where we have pitched circular motion of an object going around in a circle. So if you haven't watched that video, go back, check it out, see how we get tx, see how we get ty, because that is what we're going to be using in this problem. In our problem down here, we've got a flying pig, and you might have seen these at the store before. They're little pigs that you hang from a rope from the ceiling, and they move around in these nice little circles here. Based on the derivation we kind of did before, we know there's a weight here on the pig. We know that there is some tension pulling it up to the right, and we know that there are two components of this tension force, Ty and Tx. And we know that Tx here is going to equal the tension multiplied by the sine of theta, and we know that Ty is going to equal the tension multiplied by the cosine of theta. And if you haven't watched those videos, like I said, watch that previous video, see that derivation, see how we work through that. So in our problem here, and these are just numbers that were given to me by students just moments ago, we have a 50 kilogram pig. So our mass here is 50 kilograms. And the radius of the circle that pig is flying around is a wonderful 27 meters, because that's easy to multiply and divide by. And the angle that this pig is moving at, the angle from the vertical, so this angle right here, which is this angle, which are these angles, our angle theta is 30 degrees. And that's actually a nice angle. Sine and cosine are pretty well known at 30 degrees. So let's actually calculate what the tension in the rope is here. Well, the one thing that we do know in this problem, just right off the bat, is we actually know what the weight is. We know weight is mass times gravity. And if we go back into that derivation up top, we know that the y component here, the cosine component, the position acting up, has to hold this pig at some height. As this pig is going around in the circle, it's not rising up, it's not going down, it's holding its height. So we know that the cosine component of the tension actually has to equal mg. If we look at this right here, these two forces, we know that the y components have to add up to 0 because it's in like a vertical equilibrium. So if we call classically like up positive, down negative, what we could say with F equals ma, the classic F equals ma setup, is we could say that the tension in the y direction minus the weight equals 0. Or, therefore, the tension in the y direction equals the weight. And this means for us pretty quickly that the tension multiplied by the cosine of our angle, which is 30 degrees, has to equal mass times gravity. And the mass of our pig was 50 kilograms times gravity, which is 9.8. Play a little bit of mathematics. So we divide by the entire cosine of 30 degrees. Remember, that's an entire term there. So divide by the cosine of 30 degrees. And that gives us our tension. So we pretty quickly find our tension here. And if we just math this out, 50 times 9.8 be a little under 500. So it's 490 divided by the cosine of 30. And what we find there is we get a value of 565.8 newtons. And that is the tension in our line. So that is the actual tension right here that we have. Okay, so that's the amount of tension in the rope. And that makes sense because, if you imagine spinning this around, the tension's going to be more than just the weight of the pig. Okay, so 565.8 newtons is what we find right here. Now, from that, could we actually find the speed at which the pig is going around? And we absolutely can. We can use this using a centripetal force idea. So remember, the centripetal force has to be equal to the mass times the centripetal acceleration, which is v squared over r. And our centripetal force is an inward acting force. Well, the only force that we have acting towards the center of the circle is actually Tx. That is the force that is acting inwards on the circle the entire time it's going around. And we know Tx equals T multiplied by the sine of theta. So since that's the only inward acting force, that's the only force we need to consider for our centripetal force, and since it is acting towards the center of the circle, we can call it positive. So this is just Tx here, which we know is just T multiplied by the sine of theta, and that has to equal mv squared over r. Now let's just solve this for v first, and then we'll put in some numbers, make life a little bit easier. We're going to multiply by r so that these r's go away. We get an r over here. And then we're going to have to divide by the mass, so the mass goes away. We get a mass over here in the denominator. And then if I want to get rid of this square root, whooshing, well, if I need to get rid of the square, I need to take the square root of this entire term. So we actually find for our tension, or for our velocity here, is we find that our velocity is equal to the square root of this entire quantity of the radius multiplied by the tension multiplied by the sine of the angle divided by the mass. And maybe you've been learning this in your math classes. You could also write this with parentheses, RT sine of theta divided by m to the 1/2 power. So maybe that looks a little better for you if you're writing that out. Just however you like to do it. Either way, we can finally solve this problem out. We know the velocity is going to be equal to the square root of the radius of 27 meters, multiply the tension of 565.8, that's what we just found in the prior example, multiplied by the sine of 30 degrees, because that's the angle that the pig is flying at. And then we need to divide that by the mass of 50 kilograms. And if we multiply all of that together and then take the square root, we'll get our answer. So 27 times 565.8 gives me 15,276.6 times the sine of 30, which is like the same as multiplying by 1/2 or dividing by 2. We get 7,638.3. We divide that by 50. We get 152.76. And then we take the square root of that value. And what we find at the end is that the velocity of our pig equals 12.36 meters per second. And that is the tangential, the linear velocity. So if for whatever reason you cut the line holding that pig in, it would just start moving in a straight line at 12.36 meters per second. And that's our whole problem there. The key to it was just recognizing, hey, we've got centripetal motion here. We know how to break this up using SOHCAHTOA and seeing from the prior videos. We know that our vertical components, our vertical forces here, the Y tension and the weight, have to be equal for our pig to stay at a level height. So we used that idea to figure out what the tension was. And then coming down to use our centripetal idea, we were able to easily find that velocity with a little bit of algebra. So with that, this problem is finished. And our practice problem that we'll be doing in a little bit, we'll be looking at another one of these kind of hanging problems of pitched circular motion. And then we'll also be looking at a banked curve of a car going around a track. So stay tuned for those. But for now, adios and take it easy.